was a well-distinguished early 20th century scientist and physicist. He is well known for his studies on the properties and measurements of charges carried by electrons. Born in 1868 in Morrison, Illinois, Robert Millikan went on to receive a doctorate in physics from Columbia University in 1895. From there, he went on to lead an illustrious career as a scientist, conducting the famous oil drop experiment, which he designed to measure the elementary electric charge, otherwise known as the charge of the electron. His scientific career was then finally recognized in 1923 when he received the Nobel Prize for Physics for his oil drop experiment and his work on the photoelectric effect. Overall, he contributed much to the scientific community and with his research on the electron and its properties.
The oil drop experiment was performed in 1909. He balanced the downward gravitational force and the upward electrical and buoyant forces of the charged electrical oil droplets using falling drop method. He also proved that this quantity was a constant for all electrons. When the oil drop is motionless, then only two forces act upon the drop. The electric force acts up, and the gravitational force acts down. These forces must be balanced if the drop is not moving. By finding this balance, Milikan is able to find the charge on individual electrons.
In 1909, Robert Milikan, working at the University of Chicago, succeeded in measuring the charge on the electron. He allowed a fine spray of oil to settle through a hole into a chamber where he could observe their fall. The top and bottom of the chamber consisted of electrically charged plates. He introduced a source of X-rays which can cause creation of charges when they strike matter. Charges produced by the X-rays attach to an oil droplet, producing one or more charges on the droplet. When there is no voltage applied, the fall of the droplets is determined by their mass and the viscosity of air through which they fall. When a voltage is applied, the droplets that have a negative charge will fall more slowly, stop falling, or even rise, depending on the number of charges on them. By adjusting the applied voltage and observing the droplets both with voltage off and voltage on, Milikan was able to determine that the charges on the droplets were all multiples of a smallest value, 1.6 times 10 to the minus 19th coulombs. He took this to be the charge on a single electron.
Out of this experiment, Milikan proved that the change of the charge on oil droplets is always equal to Ne, where N is a separate constant called Avogadro's number. The product Ne came out of observations of Brownian motion. In order to conduct this experiment, Milikan had to make up some fiddle factors in his calculations because no one really knew how drops that small really fell through air. Milikan determined the charge on a drop. Then he redid the experiment numerous times, each time varying the strength of the X-rays ionizing the air so that different numbers of electrons would jump onto the oil molecules each time. He obtained various values for Q. The charge Q on a drop was always a multiple of 1.6 times 10 to the negative 19th coulombs, the charge on a single electron. This number was one Milikan was looking for, and it also showed that the value was quantized. The smallest unit of charge was this amount, and it was the charge on a single electron. His final paper in 1913 included the measurements on only 58 drops out of all of the ones that he experimented upon. However, what many people don't know is Professor Milikan actually stole credit in return for Harvey Fletcher claiming full authorship on a related result for his dissertation. Milikan went on to win the 1923 Nobel Prize for Physics in part for this work, and Fletcher kept the agreement as a secret until his death.
Decided to experiment upon the physicist J.J. Thomson's encounter of the electron in 1897. J.J. Thomson had previously hypothesized that the mass of a single electron was at least 1,000 times smaller than that of the smallest atom. Milikan utilized his theory by conducting an experiment using J.J.'s discovery of the electron and his study of the nature of positively charged